Hi and welcome to the fifth part of this new tutorial series. In this part we will draw a cube to the screen. So there are multiple ways to draw something in OpenGL, but people use the most simple one for now. So go to your render method and begin by typing GL begin with argument GL quads and GL, and then call the function GL end. Now between GL begin and GL end we will specify the vertices of our cube. So I'll open Paint tab. So say this is our cube we are going to draw. It has four vertices. It has this one, the bottom left, the bottom right, and the top right and the top left. The center has coordinates 0, 0. The bottom left has -1, -1, and so on. So we have to specify 4 vertices. The first one, and to do that we type GL vertex 2D, and then you type for the first argument 0.5f and 0.5f again. Now it's actually minus 0.5. Now I'll just copy and paste this 4 times. Now this is our bottom left one. Now for our bottom right one, just have to change the x coordinate from negative to positive, and now we have our bottom right one. Now for our top one, so our top right one, we change both coordinates to positive, and and for our last one we just keep our x1 negative, and we change our I1 to positive. So if you run this application now, we get nothing. So that's because we haven't specified the color. To do that, you just have to call the function GL color 3f, and say we want a red one, so we just do 0. So again, RGB, and it runs from 0 to 1. So by specifying in the first argument we want full red intensity, and if you run this now we get this red rectangle. Now you may have noticed that these sides that the horizontal sides are longer than the vertical sides, and if you look at our coordinates, that's really not right, because yeah, the distance between the top and the bottom is the same as the distance between left and right. So that's because in the viewport, this is the center, and going up it goes up to 1, it goes down to -1, and it goes right to 1 and goes left to -1. But because the window in the width is bigger than in the height, the rectangle looks stretched. To fix this we have to call a couple of functions. The first one is GL viewport. Oh yeah, and we do this in the game constructor viewport. So here we have 4 arguments. The first one will be our bottom or bottom left, and yeah, so essentially the first two define our bottom and they are both going to be 0. So 0.0f, the second one also. Now for our width and our height. Okay, so first thing, actually I will comment this out for a second. In our game window, our initialization list, running, and yeah, I'll do it like this, it's better. Now, make two new variables. Make them both, actually make them a GL float even. GL float. So this one will be the height, and one more GL float and underscore GL float width. And in our initialization list, declare them. So height will be 800, and our width will be 800 multiplied by 16 divided by 9. So the aspect ratio. Okay. Then return to the viewport function. So just put in width for the third one and height for the second one, the fourth one. Now if you run this, there will be no change whatsoever. That's because we have to change something called projection matrix. Essentially, it defines the coordinate system of OpenGL. So to do that, we have to change the current matrix to the projection matrix. Default, the current matrix is the model view matrix. So to change the matrix to the projection matrix, we have to call the function GL matrix mode with argument GL underscore projection. Then then call glue ortho 2D, and here we shall define a new coordinate system. So first we have to define the left side of our screen, and that will be 0. The right one will be the width, the bottom will be 0, and the top will be height. And when we've done changing the projection matrix, we change the matrix mode, so GL matrix mode back to the model view. Now if we run this, you'll get nothing. That's because, and I'll explain why in a second, but first, in your render method, a couple of changes. So the first one will change to 0, 0. The second one will be 100 and 0. Then our top right one will be 2 times 100. And our last one will be 0 and 100. So if we run this, now we get a square, an actual square. So our new coordinate system runs from 0 in the bottom left corner of the screen to whatever 800 multiplied by 16 divided by 9 is in the bottom right corner of the screen, and then the top right corner is 800, and this one is 0 for the I coordinate. The old one began in the center, plus its origin point, and in this new one, the origin point is the bottom left. So that's it for this video. Next video we will introduce vertex arrays into our application, which is a more efficient way to render geometry and to store geometry. So see you next time.